Let's wait a couple of minutes for everyone to join. It was a long time since we had our last community call. So while you're still joining, guys, how are you doing? How was your day? Great. I see thumbs up from Bernard and Mike. Okay, so let's wait for another minute and start our community call. Okay, so I guess it's already time to start. So again, hello everyone. It's so nice to see you here. This is Fluent's Developer Community Call for 24, and let's see what we have on our agenda. So today we will talk about the proof of capacity update we will be rolling out by the mainnet launch. We'll also talk about progress highlights from our core tech team and have the Q&A session with them. We also share our consensus and Computer Over Data Summit highlights and have the Q&As on them, and also share like our future events, and of course hand out our POAPs. Right, so first things first, Evgeny is going to tell us about the proof of capacity. Evgeny, hi.
Hello. Yeah, can you just switch to the next slide? Yeah. I would probably like give very short introduction, just a reminder to everyone, like big part of Fluence project is creating the marketplace of compute providers, right? Because we don't run servers ourselves. We are not a centralized company. We are not trying to replace clouds with another company that runs servers. So we create a protocol and a marketplace, so anyone of compute providers can join the network and be provider host users, applications, functions, and earn money. So as a part of protocol and as a part of marketplace, we have basically what we call like proofs of either processing or execution or capacity. Proofs of processing and execution are related to basically security of computations that happen in Fluence and verifiability of computations that happen in Fluence. Like whenever customers, developers deploy their applications, their functions to providers, basically as a part of executing those applications, providers have to create and submit proofs that are verified on chain. And you know, the designs of these things are still not yet fully finalized, but proof of processing related to Aqua, it's basically about ability to verify certain particles that were issued by applications. Proof of execution were named as a name for verifiability of marine function calls. So basically, when our particle is verified, it could be verified very different ways. It could be like audited by like whether particle corresponds to the script that's in their IR script, or for example, IR script plus peers that's supposed to execute it, or IR script plus peers plus service calls results. So the particular definition of these proofs is still kind of work in progress, but that's the scope of these proofs. So these proofs cover the security of computational Fluence network, and the whole idea is that you don't need to trust the provider, that providers do their work correctly. Like you have this probabilistic verification that allows you to use this network in a trustless fashion. And then another big thing is proof capacity. And what is proof capacity? Is basically the idea to incentivize providers to bring compute capacity to a network, even if there is not yet enough demand from customers who want to use all this capacity. So it's basically, if you switch to the next slide. Yeah, so basically proof of capacity is some sort of work that providers have to perform constantly to prove that they allocate resources to a network at the moment. So they have to put some collaterals, they have to lock some collateral, they have to promise that they will be serving some CPU memory resource to a network over a particular period of time. And then during this period of time, they have to constantly say, yeah, I'm still allocating these resources for Fluence network. They are not allocated to something else. So I haven't switched them to something else. So I need to constantly prove that I'm still allocating these resources, and this all we call proof capacity. And we consider different ways to approach this method, but basically it's a kind of proof of work, a little bit similar to proof of work, the whole idea that it should be ASIC resistance, because we don't want ASICs to be on the network instead of real servers that are ready to switch to serve user demand. And it should be this mechanism should include token collaterals, because we are interested in providers to commit providing resources for a long period of time, so they have to put some stake up front. And they should earn some rewards for providing this capacity, so it's economically makes sense for them to do it. And this approach is actually like used in Filecoin network, for example. And Filecoin basically rewards storage providers to provide storage capacity to a network, even if it's not used at the moment by useful data, and then gradually this capacity migrates to serving useful data. And this is very similar logic. A lot of these things are still work in progress, like a lot of details. That's why we're not publishing any kind of documents on it yet. But we consider this as a important part of the mainnet launch. So basically, Fluence mainnet should start from incentivizing the compute providers to join, to like expand the basically supply side, the compute capacity side, and then start gradually onboarding the customers from developers to this marketplace. Yeah, I think that's a rough overview on this. It's more or less everything on my side, and I think we would have some discussion later related some pieces of it, right? Because we're gonna talk about signatures that's related to proof processing, and but I'm not sure if you have anything on proof capacity on agenda. Yeah, but that's roughly like a rough overview for everyone to know what we are, like what are some of directions we are working towards.
Okay, thank you so much. Yeah, right now it's part where we discuss the highlights from our core tech team. So I can give you the brief overview of what we're going to talk about. So first of all, we have released and added support for Docker images with ARM64 architecture. It means that right now developers can use M1, M and M2 Max and get like the native binaries for them. So we're also releasing particle signatures, and Mike, you're gonna tell about this a little bit more shortly. And we're also introducing some new updates into Fluence CLI, and we are going to sunset Aqua CLI. So we have transferred most of the functionality into Fluence CLI, and we're going to stop supporting Aqua CLI in future releases. So right now I'm going to pass the mic to Mike. So he's going to tell us about particle signatures.
Yeah, hi there. So as Evgeny said, so we are working now on a proof of processing. So like basically now we almost designed how it should be, and we have some missing pieces like that needed for this proof of processing. And one of them is the signatures, or in other words, is proof carrying data. But before we're going to talk about proof carrying data, let me briefly explain what we're doing, like in kind of more low-level terms, and how our network is structured, and how we want to actually submit this proof of processing to the on-chain part. So on this slide, you could see like this kind of scheme with several Aqua VMs. So Aqua VMs is a interpreter that interprets like AIR code. So that AIR is resulted from Aqua compilation of Aqua. And Fedor, could you please swipe to the next slide? And actually, it's important that every peer in the Fluence network contains like hosts this Aqua VM. Particle. So there is another conception is a particle. Particle is you could consider it as a network packet that's like going from one peer to another. Yep, and this particle is basically handled by Aqua VMs. So like all peers, all runtimes, all of this is kind of controlled or ruled by Aqua VM. So Aqua VM tells how exactly network should behave. And could you further please swipe to the next slide? Yes, thank you very much. So, and regarding proof of processing, basically we'll have division to two parts, off-chain and on-chain. So now we're thinking that the on-chain part will be on the Filecoin, and on this slide you could see how like a principal scheme of how like it could be, it could work. So basically, every peer or every Aqua VM on peer mines a particle. Yeah, by mining I mean that every peer after like a new particle created, it checks its hash against some another hash. Yeah, like in a general proof of work. And if this hash satisfies this complexity or like another hash, it doesn't matter, then this peer like mined a particular hash and can submit it to on-chain part. And submit it not just hash, but data that's verifies that this like execution was done correctly. Yeah, that this was actually done. And on this slide, you could see that like this peer, one of the three peers, submits so-called golden network packet or golden particle with proofs, some proofs to the on-chain. And it's important that every peer that's participated in forming of this particle, or this like in a particular execution, participated in this particular particle execution, they will be rewarded. So that's for every peer, it's important to kind of check particles against the complexity and submit if they're kind of satisfied as complexity. And also it's important to send it next to next peers. Yeah, because like all next peers have the same probability to mine this golden particle. So that's how it should work, like in general. But there are some missing pieces in the scheme. And further, could you please move to the next slide? Yeah. And basically, there are some requirements that we haven't met before. Like, first of all, peers must not be able to tamper data. So it's connected to the last last point of this list is peers must not be able to grind data. Yeah, so like if peer somehow like compute hashes of data and then it should be satisfied to some complexity, then these peers, they can grind data. They could like iteratively change something in data and just do this mining, not useful work. And also they can tamper like for example call results of calls that were done on previous peers, like peers that like before this execution. Also on-chain layer should be able to verify particle according to error scripts. Yeah, they should be able to check these proofs according to submitted particle. And also like for having this like ability to having like computing proof of work, computing hash, we need a reliable source of entropy. Yeah, so now at the moment we like before like the last updates, we haven't had this, but now with this proof carrying data, we can use signatures as a source of entropy. Further, could you please go to the next slide? Yep, and a couple of words about signatures and about how Aqua VM works internally. So basically, Aqua VM has no any saved entry point. So and when like each target execution, when particle came to Aqua VM, execution starts from the very beginning. So it means that Aqua VM starts from the first instruction and checks like if it was already executed, then it checks that the result is correct. If not, it tries to execute it. Yep, and to prevent execution of the same calls, like for example calls or any other instruction twice, execution trace is linearized and serialized in some form. On this slide, you could see the previous incarnation of this form. basically we had 4 states. So like only for 4 instructions, it's par, cow, fold, and up. We had states in this trace. Yeah, and on the right side, on these 2 pictures on the right side, you could see that how they structured for par and cow. It's doesn't matter how exactly, but you see maybe some points here, some heuristics. How what are they basically? And after this, well, the y-axis changes. So Fedor, could you please go to the next slide? We highly refactored our trace, and now it's heavily CID based. On the picture on the right side, you see how like all this linked together. It's rather complex, and we won't kind of spend much time on that. If you have any question, please ask on the Q&A session. But this scheme is important for proof carrying data. For example, these CIDs are used for signatures. Okay, so basically, after like particle execution on every peer, AquaVM signs all necessary data, and data signed by CID. So basically, we combine all CIDs, sort them, and then sign all this like final list. And then before and even while executing AquaVM on like every next peer, we check that all signatures are correct, yeah, and no data was tampered. So these signatures are quite important also for source of entropy that I already said, yeah, because it's a natural actually source of entropy, because it signs with a secret peer keys, and kind of it's not so easy to like kind of grind particles in this way, hash of particles in this way. So basically now we are like kind of trying to release it to network. It's almost done in AquaVM. So by almost, I mean that we have like a final pull request that's not yet merged, but it was made. And now we are also simultaneously working on releasing it to the network, and hope that next week we'll finally have it on the network. So it's basically all for signatures of proof carrying data. So if you have any question, please ask.
Mike, thank you so much. I guess that's we can have like the Q&A session after like the whole part about the team tech updates. Artem, would you like to tell us about the CLI updates?
Sure. Hello. Yeah, thanks. Let me share my screen. Can you see it?
Yes.
Okay, so I will tell you a little bit about the recent updates for Fluent CLI, what we did last month. So one of the things is checking for updates. And, this is a feature. It's just for CLI to check for updates. You will still have to install the CLI yourself, but at least you will know that new version came out. There is also a new property in Fluent YAML that lets you pin a project to a particular CLI version. It will ensure that all the versions of every component are compatible with the exact setup of your project. You can also check the version of the Rust peer that is used with your project. So this is just a way if you want to make sure that your project works in the future, even if the network updates. There is also a no build flag for deployment, and for some other commands. It just allows you to not build the project when you deploy, because by default it is built before deploying. This is just allows you to do some stuff if you want to, for example, assign WAS module before deploying. We also did a little bit of testing, and now our core commands and core workflows with the CLI are tested and working in CI, so it makes everything more stable now, because we can check that everything works on each commit, and that's very good. There is a small feature for supporting YAML extensions, which were previously not supported. Also, we did auto commit in Fluent CLI repo that it's just for developers, so it is easier to contribute for them, because the GitHub bot Actions bot does all the formatting, linting, and generating docs for you. And speaking about docs, we found a better library for config docs generation. So now, if you want to learn about configs, their docs are now a bit better, but still there is a room for improvement. And as further told you previously, we're trying to sunset Aqua CLI, and it was removed. And now Aqua API is used in Fluent CLI code. It enabled us this feature that people complained about. Previously, we supported only Node 16 version. Now it's LTS version 18. So please update in order to use the CLI. Also, we added a tracing flag for some of the commands in the CLI, and what this allows is it prints all logs from Aqua function calls as they happen. So it basically, when Aqua is compiled, special calls back to your own peer that is inside Fluent CLI are made, and you can see the logs of functions happening like in real time. So we added AirBeatify into a CLI. This is a command that prints Air scripts in human-readable Python-like representation. It's not executable, but it can be used to easily read and understand Air code. You can also use a B flag when doing Fluent run to display a beautified Air script. So you can make sure what exactly you are running when you do Fluent run. There is also a quick start template in Fluent CLI. It's just streamlines the user journey, like our main journey of deploying and running what you deployed. So you can just init and do a deploy right away and run the default service, which is like a part of this template. It's just hello world service. And the most recent feature, Apple now downloaded as pre-built binaries. Previously, they were built from the source code by CLI, and it took a lot of time. And now this process is a lot faster. So please check it out. There are also lots of other fixes, small improvements, and refactorings. And that's pretty much it. Thank you.
John, thank you so much. Thank you so much for sharing the updates on the CLI with us. Any questions for Artem and Mike?
Hello, Sami Levitt. And the slides are done with smart questions, but Artyom, can you show us beautified air code?
I can try.
No.
Let me
Right.
share my screen again. If it looks a little bit like Python. Let me just find something to show. Sorry for that. Let me check. There is some core function. Let's do hello world and check out how this looks. I need to provide some arguments. So yeah, that's basically how it looks like. It's a little bit more readable if you're like familiar with Air and how it looks like. This looks a little bit different, but arguably it's more readable and easier to understand.
Okay.
Thanks.
Yeah, I never looked at it, so that's something already. Okay.
That's what is actually running when you do Aqua Run, running your Aqua code. It is compiled into this Air representation, and to easier understand the Air code.
Like a few line breaks, so that the try and then the line break to the call thing and everything. It used to be in one line.
Yeah, the actual Air looks a little bit different. We can like display how the Air looks like with the print Air. So this is the Air code, and this is the beautified version.
I was hoping for colors, but you know, then there can still be colors.
Yeah, I also asked the machines team about the colors, but currently there is no plans for that, unfortunately.
Hey, the fixed CLI version and the updates, and then you said something about that it would like also check on the Raspberry version. Or let's say
it will not check for Raspberry version, but if you use are you asking about this, right?
Yeah, so if I'm fixing a particular CLI version, and
yes, if you pin
so probably I have an Aqua version related to my CLI version, and I'm like doing nothing for a year, and then all the nodes in the network have a higher Aqua version.
Yes.
Will it then say like sorry?
I understand. No, it's not that as good as you would hope, but if you pin the version of CLI, you effectively allow this project to be used only with this version of CLI. And if you use a particular CLI version, you can do Fluence dependency v, a version command. And here you will be able to see all the components and all of their versions, including the Raspberry version that was used together with this project at that moment that you used it. So if you wanted to run your project, you can spin up your own part of network in Docker Compose with this version, and check out your project and how it was working. It only may be useful in this regard. Yeah,
The local node, it's not the
yeah,
it's not checking the remotes ones.
yeah. Not as good as you would hope.
Well, there is lots of time to, yeah, I don't know, maybe it's not even useful, my thought. Yeah, Mike, sorry, I'm gonna review everything you said and then try to understand it at another time, because today was not working. It
I
was,
can share with you our proposal if you want.
Hmm?
I can share. So, like everything that I have said, everything are written in a so-called proposal. So we have internal proposals,
I
and I
remember.
can share it with you if you want.
Okay, and I'll be probably in 2-3 weeks, I will have more time again.
Okay.
That were all my questions.
Excuse me. As of color support, it's not about plans, it's about library support, because the library that I tried before, it doesn't support colored output when compiled to WASM, and the beautifier in air utility, in Fluence utility, it is built as a WASM model. So if we will be able to find a library that produces colored support for WASM for console in WASM, it would be possible to produce colored output.
Well, I don't think it has a very high price. Although that's me saying it. Anyway, I'm shutting up.
Okay, Yura, thank you for your questions. Artem, thanks again for showing us the air beautifier. Okay, so now it's time to take a look at our participation in the consensus. Nadia?
Yeah, it was a while ago, but still we didn't share any highlights from consensus. But yeah, we've been at the end of April, we've been to consensus. It was pretty intense week. We had a lot of networking, we had a lot of talks and participated in the main event of consensus, having a booth there, and at a lot of Filecoin events. One of them are Filecoin network base, and also Disco Summit, which is like decentralized compute community sharing sharing their thoughts on everything what's going on in the space. So that was pretty good for us. And also Tom had 2 talks, which is on our YouTube right now, so you can check this out and learn more about the recent updates about the project from these videos as well. After consensus, we had participated in Compute Over Data Summit, which was not as huge as consensus, but still very, very productive for us. Actually, we don't have any pictures from there, but we have Bernard's talk, which is also you can find at our YouTube channel. Yeah. Yeah, we can go to the next slide. And of course, we had our internal summit in Belgrade, which was very, very intense. We spent the whole week all together in planning and working. A lot of strategic sessions and a lot of brainstorming and planning our mainnet and the future roadmap as well. Yes, that was pretty good. And for the future events, we're planning to go to ECC Paris in July, also to DevCon in Berlin and to Token 2049 in Singapore. Also, we probably will be in Istanbul for the DevConnect week and maybe something else. But this is the closest one, and Paris is coming pretty soon. Let's go to the next slide. There is a really brief agenda of what we are planning. So we're gonna be at the main event of EthCC. We're gonna have our booth there for the first 2 days. And also Dmitry probably will come and give a talk. So if you're interested and if you will be around, so please join us there at the main event. And of course, at a lot of side events, we are mostly concentrated on Filecoin events. So yeah, check us out at Filecoin Network Based and Launchpad. Further, we're gonna participate in Launchpad activities, CryptoCon Day, and many more. Also, we're gonna organize our Decentralized Compute Summit. I believe we're gonna have more information next week at our Twitter, so stay tuned. I believe it's gonna be huge this time. And as for ETH Global Paris, this is a pretty famous hackathon. We are not like really deeply participate there, but you have an opportunity to go there with a scholarship. Can we go to the next slide? So the same as we did for ETH Denver, we're also doing for ETH Global Paris together with developer DAO community. So yeah, so anyone who would like to go to Paris can apply for the scholarship. So all you need to is to have a team and ability to build on top of our project. So yeah, if you are able to go, if you can scan QR code and apply, you'll be able to go to Paris for free, and yeah, and win the prize. That's pretty much it. I believe we're going to share more about the upcoming events during next community calls. I think it's too early to share the plans for Berlin and for Singapore yet. That's it, probably from my side. Yeah. So yeah, we also have POAPs today. I think I'll send everything over later a little bit. Yeah, let me just meet the links.
Okay, Nadia, thank you so much. We'll be waiting for that POAP link. So guys, it looks like we have ran out of content for our community call. So thank you for attending. Thank you for joining. Any questions while we still have time? Well, if there are no questions, then let's conclude our call. Again, thanks you for joining. Thank you for your participation, for your questions, and see you on the next community calls, guys. Thank you. Bye-bye.
But